to The Perfect Stool, Understanding and Healing the Gut Microbiome. This is your host, Lindsay Parsons, and today we're exploring a topic that impacts us all, food additives. From the preservatives that keep our food fresh to the artificial sweeteners that replace sugar in our low-calorie sodas, these substances play a major part in the modern American diet. But what do they really do to our bodies, particularly to our gut? In this episode, we'll look at preservatives, emulsifiers, pesticides, and artificial sweeteners, the hidden ingredients that fill our grocery aisles. We'll discuss their risks and the current research around their impact on the gut microbiome. Later in the episode, I'll discuss my favorite sugar alternatives, things like xylitol, allulose, and stevia, to replace those questionable artificial sweeteners. But before I delve in, if you haven't yet followed or subscribed to this show, be sure to do so. And if you want to get transcripts of the podcast, pop over to my website, highdeserthealthcoaching.com, and sign up for my newsletter. You'll also get my free e-booklet, Finding Your Root Cause Through Stool and Organic Acids Testing, when you sign up. And if you haven't yet done my quiz on which stool test would help you get to your root cause, you can find a link in the show notes and take that. Now on to the show. Let me start by saying that once again, I've bitten off more than I can chew in my topic selection, and as a result, I will cover some of these areas more thoroughly than others. So my apologies for that. But it was a holiday weekend too, and I decided to take Labor Day off, and that has limited the amount of time I could spend finishing up the script. But let's get started with preservatives, chemical compounds that extend the shelf life of products and ensure they stay safe to eat for longer periods of time. Specifically, they're added to food to prevent spoilage caused by bacteria, fungi, and other microorganisms. And they help maintain the quality, flavor, and appearance of our food, making it possible for us to enjoy a wide variety of products that would otherwise spoil quickly. Nitrates and nitrites, two types of preservatives, can be found in leafy greens and processed meat. In meat, they're used to prevent bacteria growth, enhance the pink or red color, and add saltiness. Earlier research suggested that nitrates might be responsible for the increased colon cancer rates seen in people who eat lots of processed meats, like bacon, ham, hot dogs, sausage, and sliced deli meat, although the connection is still ambiguous. That said, nitrates also act as antimicrobial agents by disrupting key bacterial functions, including metabolism, oxygen uptake, and energy production. Additionally, they're particularly effective at preventing the growth of Clostridium botulinum spores, which help to protect against foodborne illnesses like botulism. Nitrates are also naturally occurring in our bodies and in leafy greens, like kale, spinach, beets, romaine lettuce, and celery. In these cases, the nitrates are actually healthy and linked to lower rates of cancer and lower risk of heart disease. Sulfites, another food additive, are used to control microbial growth and to prevent browning and food spoilage. They can be found in beer, wine, juices, dried fruit, processed fish, seafood, meats, and some canned goods. In one study, sulfites were found to inhibit the growth of 4 species of beneficial gut bacteria, Lactobacillus casei, Lactobacillus plantarum, L. rhamnosus, and Streptococcus thermophilus, which are commonly used in probiotic supplements and fermented foods. Another study showed sulfites causing a decrease in bifidobacteria and an increase in the genuses Escherichia and Shigella, the former containing both harmful and beneficial microbes, the latter being fully pathogenic and the leading cause of bacterial diarrhea worldwide. Sodium benzoate was the first food preservative approved by the Food and Drug Administration, and it's usually added to carbonated drinks and acidic products or sauces. Unlike sulfites, there may be a positive effect associated with sodium benzoate. A 2023 study showed that it helped regulate gut microbiotic composition and improve bacterial diversity. It was proven to increase the abundances of certain beneficial bacteria, including bifidobacteria, and decrease the abundance of certain harmful bacteria. So there are helpful preservatives, harmful preservatives, natural nitrates, unnatural nitrates. The world of preservatives is complex. But less complex is the emulsifiers, another food additive. Emulsifiers help to combine ingredients that don't normally mix, like oil and water. When used as food additives, they keep products smooth and uniform, supporting the texture, flavor, and shelf life of food products, and they basically act as binders. We can find emulsifiers everywhere in grocery stores, in lunch meat, in pre-prepared sauces, in ice cream, mayonnaise, baked goods. There's evidence that these emulsifiers, especially 2 common ones, CMC or carboxymethylcellulose and P80 or polysorbate 80, decrease the diversity of gut bacteria. Importantly, Faecalibacterium for P80, which you may know that Faecalibacterium presnitzii is an important commensal bacterium that produces butyrate in the colon and that I often see missing on clients' stool tests. These emulsifiers wear away at the mucus wall that protects the gut lining. As a result, bacteria come much closer to the lining, causing inflammation and a leaky gut. This can spark inflammatory diseases like Crohn's and ulcerative colitis in genetically susceptible individuals. Polysorbate 80 also increased Bilophila, which you may recognize as the genus containing Bilophila wadsworthia, one of the prime culprits in hydrogen sulfide, SIBO. Another commonly used emulsifier, often found in dairy products, is carrageenan. Much like other emulsifiers, it's found in ice cream and deli meats, but also in reduced fat or non-fat food products like soy milk, yogurt, chocolate milk, salad dressings, and beer. It's also used as a browning inhibitor for fresh fruit, and it too decreases the thickness of the mucus barrier, and clinical evidence suggests that carrageenan is linked to the development of inflammatory bowel diseases. Carrageenan may also interfere with the normal digestive process by reducing the effectiveness of gastric juices, potentially leading to incomplete or impaired protein digestion and nutrient absorption. It also increases the genuses Escherichia and Shigella. So while the emulsifiers I've mentioned aren't great for any of us, they're particularly important to avoid for people who have inflammatory bowel disease, meaning Crohn's or colitis, or anyone with first-degree relatives with those diseases. Another common food additive, maltodextrin, is a preservative, thickener, and bulking agent derived from either corn, potato, rice, wheat, or tapioca starches. It's been shown to increase propionic acid, one of the short-chain fatty acids in the colon, but which at elevated levels has been associated with autism spectrum disorder. On the other hand, maltodextrin increased bifidobacteria, an important commensal. Another study found that it led to the promotion of intestinal inflammation and could be a risk factor for chronic inflammatory diseases, including a mouse model of colitis. It was also found to favor biofilm formation by adherent invasive E. coli bacteria associated with Crohn's disease. Emulsifiers and preservatives are just one part of the broader picture when it comes to additives. But before we eat these products, and even long before they find their way to shelves in supermarkets, we need to worry about pesticides. There are several types of pesticides, including insecticides, herbicides, and fungicides, bactericides, each tailored to combat specific types of pests. The term pesticide encompasses a wide range of chemical substances used to manage and eliminate pests like insects, rodents, fungi, and undesirable plants like weeds. Government agencies and the World Health Organization have placed limits and enacted laws over the permissible levels of pesticide use. But fears around the use of pesticides still permeate, and sometimes for good reason. Studies have shown that exposure to organophosphorus insecticides, or OPs, are correlated with behavioral deficits, obesity, and asthma. In terms of the gut and its reaction to pesticides, animal experiments suggest that OPs and several other pesticides, including the herbicide glyphosate, can affect the gut microbiota. Short-chain fatty acids and polyamine-producing intestinal microbiota are particularly affected and altered by pesticides. Short-chain fatty acids protect the intestinal barrier and regulate the immune response to infections. They're essential to the functioning of a healthy gut and also help process nutrients, maintain energy homeostasis, and assist with immune system development overall. Polyamines, on the other hand, are essential for cell growth and proliferation, as well as suppressing chronic inflammation. Several studies in recent years have focused on glyphosate, the most popular herbicide, used to combat unwanted plants and grasses. Most of the time, these are animal studies, and things haven't been tested on humans yet. But the results are interesting and may shed light on the effect of pesticides on humans. For example, one study looked at the effect of glyphosate exposure on a specific kind of mussel. The results showed that glyphosate changed bacterial species growth in these mussels, potentially leading to microbiota dysbiosis, which could then promote the spread of opportunistic pathogens. In another study, glyphosate exposure led to a reduction in a digestive enzyme function in a type of crab. While there aren't many studies on the effects of glyphosate on humans, a 2023 paper published out of the UC Berkeley School of Public Health shows that childhood exposure of glyphosate is linked to liver inflammation and metabolic disorders in early adulthood. These children were exposed via agricultural use of glyphosate near their homes and near the homes of their pregnant mothers before they were born. And the researchers measured glyphosate in urine samples from the children at age 5, 14, and 18. Higher rates of glyphosate residue in urine in childhood and adolescence were associated with higher risk of liver inflammation and metabolic disorders at age 18. It was also reported that the diet was likely a major source of glyphosate exposure. Another food additive, and among the most commonly used globally, are artificial and alternative sweeteners. Their lower zero-calorie content, affordability, and intense sweetness, and the growing awareness of the detrimental effects of sugar have led to their growing use as sugar substitutes in various foods and beverages, including sugar-free desserts and sodas. But you definitely can't lump all the alternative and artificial sweeteners in the same boat. Aspartame, an additive found in diet products, including soda, may be one of these risky artificial sweeteners. According to a 2014 study conducted on rats, aspartame was found to increase the circulatory level of the short-chain fatty acid propionate. Increased propionate in the bloodstream can disrupt normal metabolic processes. The same study found an increase in gluconeogenesis after aspartame intake. Gluconeogenesis is the process by which the liver produces glucose from non-carbohydrate sources. If it increases, it can lead to higher blood sugar levels, which can in turn contribute to conditions like hyperglycemia and insulin resistance. But there's a lot of debate around the effects of aspartame. While some studies suggest there are negative metabolic consequences associated with this artificial sweetener, others suggest there may be minimal effects on the gut microbiota. Another study, this time conducted on humans in 2020, showed a drastically different picture of aspartame. There were a total of 17 healthy participants who, over the course of 12 weeks, consumed both aspartame and sucralose, another artificial sweetener. The results suggested that aspartame and sucralose did not cause measurable changes in the gut microbiota or in short-chain fatty acids after 14 days of a realistic intake of these sweeteners. Of course, this gives me little comfort in that I assume a realistic intake was not the level of 12 Diet Cokes a day my new husband drinks, despite my warnings against it. They found that this realistic intake did not change glucose metabolism or insulin sensitivity in healthy adults. This tells a different story than the 2014 study. That being said, there's always shortcomings and potential limitations to this kind of research. For one thing, 14 days may not be enough to measure or track changes in the gut microbiome. Additionally, all participants were healthy and did not have any chronic medical conditions, including diabetes, IBD, IBS, celiac, or malabsorption syndrome. Furthermore, a European Food Safety Authority reevaluation of aspartame safety found that 97% of studies that reported no harm were industry-sponsored, while all of the studies that indicated possible harms were non-industry-sponsored. Similarly, a Sydney University study found that 100% of industry-sponsored studies found that aspartame was safe, while 92% of independently funded studies found adverse effects. Acesulfame potassium, also known as acesulfame K, is another low-calorie sweetener. After testing its effect on the gut microbiota in mice, the body weight of male mice significantly increased, with no significant weight change in female mice. Another study from 2015 found that there was no significant change in median bacterial abundance in human intestinal flora after exposure to acesulfame K. However, an umbrella review of multiple meta-analyses on artificially sweetened beverages done in 2023 concluded that they were associated with a higher risk of obesity, type 2 diabetes, all-cause mortality, hypertension, and cardiovascular disease incident, and weaker but still significant evidence of an association with colorectal cancer, pancreatic cancer, gastrointestinal cancer, cancer mortality, coronary artery disease, cardiovascular mortality, chronic kidney disease, and stroke. And this included beverages with acesulfame, potassium, sucralose, and aspartame. But I imagine that most of you aren't consuming these more typical artificial sweeteners, but rather considering some of the more recent and or organic sugar alternatives like sugar alcohols, stevia, and monk fruit. So let's look at some of the more popular of these. First, my personal favorite, xylitol. While this is a strange choice for me given my gut health situation with recurrent autoimmune hydrogen SIBO, because it's well known for loosening stool, I like it because it replaces sugar 1-to-1 in recipes, cooks like sugar, tastes like sugar, but does not have the bad glycemic effects of sugar, and we mostly can't digest it. Any absorbed xylitol is converted to glycogen or glucose and slowly released into the bloodstream, so it has low glycemic and low insulinemic indices. It also causes significantly slower gastric emptying. One caveat might have to do with who can safely consume xylitol, as it did show a significantly increased plasma glucose response in obese individuals, but not in lean individuals in one study. But for me as a lean individual and a recovering sugar addict who still needs something sweet every now and then, xylitol has been a practical choice. But because we only partially digest it, it does leave room for bacteria to ferment the unabsorbed portions in the colon, creating excess hydrogen, which can lead to flatulence and loose stool. But interestingly, it may also contribute to the generation of butyric acid, aka butyrate, which you know is a beneficial short-chain fatty acid, and a shift from gram-negative to gram-positive bacteria in the colon, which would be good for someone with a proteobacteria overgrowth, but not so great if you're high in Clostridia in the colon, for example. There are also several studies reporting increased oxaluria, or increased oxalates in the urine from xylitol, so people with oxalate issues should avoid xylitol. In terms of carcinogenicity, one study found an anti-cancer effect of xylitol from a mushroom that's high in xylitol, and when a xylitol solution was injected in mice as well, suggesting it might be a potential chemotherapeutic adjunct agent. But because of the stool loosening effects, I just try to keep quantities low and always reduce whatever sugar is called for in a given recipe to start with, then substitute xylitol. It is toxic to dogs, you should know, so make sure your dog doesn't grab a muffin off the counter if you're using xylitol. Also, you may have seen more xylitol gums popping up and it being touted for its anti-cavity properties. That may be a bit overblown compared to other possible sugar alcohols, but there is reasonably strong evidence for xylitol's ability to inhibit karyogenic or cavity-causing bacteria. However, xylitol in snacks doesn't seem to have the same effect, and the act of chewing gum and increasing saliva alone will help decrease cavities too, so it's a bit equivocal what the actual cause is. But it's certainly better than sugar in chewing gum. And one in vitro, meaning in a petri dish study, showed that it also inhibited Candida albicans, so xylitol gums may actually be effective for oral thrush. What's more, another in vitro trial showed that xylitol reduced the amount of acetaldehyde produced by Candida species by 84%. Acetaldehyde, you may recall, is a toxic byproduct of alcohol metabolism and of Candida metabolism that can cause significant damage to the body. And we know that sugar feeds Candida, promoting Candida growth. So xylitol may be a reasonable alternative if you have candidiasis, but don't think it's going to stop or control a Candida infection, as one in vitro study only showed a mildly inhibitory effect of a 10% xylitol solution on Candida at the day 3 mark, but not at the day 7 mark. Another very common sugar alcohol substitute you'll see in a lot of ice creams, chocolates, and other diet or keto-type products is erythritol. Like xylitol, it looks and bakes like sugar, but at a 3/4 cup sugar to 1 cup erythritol ratio. Unfortunately for me and reported others, erythritol does cause nausea in some people, and I'm one of them. This may be because of its significant slowing of gastric emptying, which was found in a randomized controlled trial of 20 people, half lean, half obese. Both the erythritol and xylitol studied in this trial caused marked increases in GLP-1, glucagon-like peptide 1, which you may recognize as the target of all these diabetic drugs that people are using for weight loss, like Ozempic, Wegovy, Mounjaro. GLP-1 and other hormones were released, which promotes satiation and reduces gastric emptying time. But because of the nausea I feel every time I eat it, I really wish some of these companies would use xylitol and not erythritol in their sugar-free ice creams. In terms of its effect on the gut microbiome, an in vitro trial showed erythritol wasn't fermented by the human gut microbiota after 24 hours, making it unlikely to be fermented in the human body. Other studies have shown that it is non-toxic and non-carcinogenic even at high doses in animals and humans. Another newer option on the market is allulose, which has shown positive impacts on the microbiome in 2 mouse studies. They indicated that allulose helps alleviate weight gain and inflammation and increases beneficial bacteria genuses Lactobacilli and Coprococcus. And a randomized control trial on humans found it safe for consumption with no effect on blood lipids, uric acid, or hsCRP, a marker of inflammation. Another pilot study in humans with type 2 diabetes compared a standard diabetic diet with a diet containing 8.5 grams of allulose and found a protective effect on insulin secretory capacity because of a reduced need for insulin. I have a bottle of liquid allulose in my pantry cupboard, and I've used it successfully to replace liquid sugars in recipes like pecan pie, which normally call for corn syrup, although like erythritol, it's slightly less sweet than sugar, so you need a cup of it to replace 3/4 cups of sugar. And I have found allulose in regular grocery stores too, which is a plus. Another great option in sugar substitutes is stevia, although not so much for baking, but more for sweetening beverages like my morning cup of Stash green chai tea, which is my total fave. Stevia has been shown in studies to be anti-karyogenic, antioxidant, and anti-tumor. And while I've heard suggestions that stevia may be bad for the gut microbiome, I found a 2022 literature review that concluded that, in fact, it may improve the microbiome's alpha diversity and that it has anti-inflammatory properties. And an interesting side note, I used to grow stevia from seed. It's a plant with leaves you can chew on, and you get that same super sweet taste. I am a fan of the better stevia drops, which come in a variety of flavors, and in my opinion have no bitter aftertaste, and I will link to those in the show notes on iHerb. Monk fruit extract is also a good alternative to stevia, although it's not my personal favorite. It's much more expensive, and although I haven't really tried it in a few years, other than in products in which it's an ingredient, I always sense a bitter aftertaste with it. But it appears to be safe and non-toxic, and in a study of a symbiotic yogurt, it even had beneficial effects on short-chain fatty acid levels and gut microbiota status in rats. However, it would be hard to separate out the effects of the yogurt versus the sweetener here, but interestingly, the yogurt actually helped restore the islets of Langerhans, which produce insulin, making the yogurt a good option for type 2 diabetics. So anyway, I hope that it helps you better decide on what food additives to focus on avoiding. If you want to avoid pesticides but can't purchase all organic, check out the Environmental Working Group's Clean 15 and Dirty Dozen lists, which I'll link to in the show notes. That's their list of fruits and vegetables with the highest and least amounts of pesticides in a given year. And I'll try to get all the references up from the article in the show notes or the latest when I publish the blog in a week. And if you're struggling with gut health issues and need some help, that's what I do for my clients. I offer a free 30-minute breakthrough session to talk about your issues and see if gut health coaching might help you resolve them. You can set that up by going to the link in the show notes. And if you'd like to support the podcast, you can buy supplements at a discount from my full script dispensary, order tests at a discount from my Rupa Health Lab store, or use my affiliate links to iHerb, which is available worldwide, or Amazon. And not just for supplements, so please bookmark my Amazon link and use it whenever you buy on Amazon, or become a regular supporter on Patreon. If you'd like to connect with me online, you can follow my High Desert Health Facebook page, join my Gut Healing Facebook group, or join my newsletter list at highdeserthealthcoaching.com, as well as follow me on Instagram, TikTok, X, or Pinterest. Links for those are in the show notes. Thanks for joining me today, and here's wishing you all the perfect stool.